Hi, my name is Shobana Krishnamurthy. Nomenclature saya D201808828287. Dan tajuknya adalah What is Transport Layer? Okay, Transport Layer is Transport Layer network in computer networking. The transport layer is a conceptual division of method in the layer architecture of protocols in the network stack in the Internet Protocol Suite and the OSI model. The protocol of this layer provide host-to-host communication services for application. Then, what is multiplexing and demultiplexing? Okay, multiplexing is gathering data from multiple application processors of sender, enveloping the data with header and sending them as a whole to the intended receiver is called as multiplexing. And what is demultiplexing? Delivering received segment at receiver side to the correct app layer processor is called as demultiplexing. Then for sending data from an application at sender side to an application at the destination side, sender must know the IP address of destination and port number of the application to which we want to transfer the data. Block diagram is shown below. So sender from X to the receiver and receiver to the sender. So the next topic is multiplexing versus demultiplexing. Okay, there are some differences between them. So the multiplexing is in a communication system. It increases the efficiency of the communication system by allowing the transmission of data such as audio and video data transmission. So in computer memory, keep up as a vast amount of memory in the computers and decrease the number of copper lines necessary to connect that memory to other parts of the computer as well. So in telephone network, it integrates the multiple audio signals on a single line of transmission. Versus the demultiplexing is in communication system, it receives the output signals from the multiplexer and converts them to the original form at the receiver end. So in arithmetic logic unit, the output of the arithmetic logic unit is fed as an input to the demux, and the OP of the demux is connected to a multiple registers. So in series to parallel converter, the serial to parallel converter is used to form parallel data. So in this method, serial data are given as an input to the demux, and a counter is attached to the demux to sense the data signal at the demux OP. And all data signals are stored. The output of demux can be read out in parallel. Thank you.
Now, let's see what is connectionless transport UDP. Connectionless protocols, in contrast, allow data to be exchanged without setting up a link between processes. Each unit of data with all the necessary information to the intended destination is transferred independent of other data packets and can travel over different paths to reach the final destination. Some data packets might be lost in transmission or might arrive out of sequence to other data packets. UDP, User Datagram Protocol, is a connectionless protocol. It is known as a datagram protocol because it is analogous to sending a letter where you don't acknowledge receipt. Examples of applications that use connectionless transport service are broadcasting and TFTP, Trivial File Transport Protocol. And then there's a picture of the UDP network diagram. Now let's go is what is the principle of reliable data transfer. The diagram illustrates the framework for our study of reliable data transfer. The service abstraction provided to the upper layer and entity is that of reliable channel through which data can be transferred. With a reliable channel, no transferred data bits are corrupted, which is flipped from 0 to 1 or vice versa, or lost, and all are delivered in the order in which they were sent. This is precisely the service model offered by TCP, Transmission Control Protocol, to the Internet application that invoke it. It is the responsibility of a reliable data transfer protocol to implement this service abstraction. This task is made difficult by the fact that the layer below the reliable data transfer protocol may be unreliable. For example, TCP is a reliable data transfer protocol that is implemented on top of an unreliable IP end-to-end network layer. More generally, the layer beneath the two reliably communicating endpoints might consist of single physical link. For example, as in the case of a link-level data transfer protocol or a global internet network, for example, as in the case of a transport level protocol. For our purpose, however, we can view this lower layer simply as unreliable point-to-point channel. In this section, we will incrementally develop the sender and receiver sides of a reliable data transfer protocol. Considering increasingly complex model of the underlying channel, the diagram illustrates the interface for our data transfer protocol. The sending side of the data transfer protocol will be invoked from above by a call to RDT_send bracket code. RDT refers to as reliable data transfer, while the _send indicates that the sending side of RDT is being called. It will be passed the data to be delivered to the upper layer at the receiving side. The first step in developing any protocol is to choose any good name. On the receiving side, RDV_RCV bracket will be called when packet arrives from the receiving side of the channel. When RDT protocols want to deliver data to the upper layer, it will do so by calling deliver_data bracket. Now, what is connection-oriented transport? TCP. TCP stands for Transfer Connection Protocol, is an example of connection-oriented transport. It requires logical connection to be established between the two processes before data is exchanged. The connection must be maintained during the entire time that communication is taking place, then released afterward. The process is much like a telephone call, where a virtual circuit is established. The caller must know the person's telephone number and the phone must be answered before the message can be delivered. TCP/IP is also a connection-oriented transport with orderly release. With orderly release, any data remaining in the buffer is sent before the connection is terminated. The release is accomplished in three-way handshake between client and server processes. The connection-oriented protocol is in the OC protocol suite. On the other hand, do not support orderly release. Application perform any handshake necessary for ensuring orderly release. Example of service that use connection-oriented transport service are Telnet, Relogin, and FTP.
Okay, next I would like to share to you about UDP versus TCP. Okay, first is difference between connection and connectionless. Okay, TCP is a connection-oriented protocol, and UDP is a connectionless protocol. So TCP establishes a connection between a sender and receiver before data can be sent. So UDP does not establish a connection before sending data. Okay, next, second is reliability. TCP is reliable. The data is sent using a TCP protocol is guaranteed to be delivered to the receiver. If the data is lost in transit, it will recover the data and resend it. So TCP will also check packets for errors and track packets so that data is not lost or corrupted. So meanwhile, UDP is unreliable. It does not provide guaranteed delivery, and a datagram packet may become corrupt or lost in transit. Okay, next is about flow control. Okay, TCP uses a flow control mechanism that ensures a sender is not overwhelming a receiver by sending too many packets at once. Okay, TCP stores data in a send buffer and receives data in a receive buffer. So when an application is ready, it will read the data from the receive buffer. If the receive buffer is full, the receiver would not be able to handle more data and would drop it. Okay, so to maintain the amount of data that can be sent to a receiver, the receiver tells the sender how much spare room in the receive buffer there is, which is receive window. Every time a packet is received, a message is sent to the sender with the value of the current receive window. So UDP does not provide flow control. With UDP, packets arrive in a continuous stream or they are dropped. Okay, next is ordering. TCP does ordering and sequencing to guarantee that packets sent from a server will be delivered to the client in the same order they were sent. On the other hand, UDP sends packets in any order. So next is speed. TCP is slower than UDP because it has a lot more to do. TCP has to establish a connection, error check, and guarantee that files are received in order they were sent. Okay, last is usage. TCP is best suited to be used for applications that require high reliability where timing is less of a concern. Okay, such as World Wide Web, HTTP, HTTPS, Secure Shell, File Transfer Protocol, Email, SMTP, IMAP, or POP. Okay, while UDP is best suited for application that require speed and efficiency. Okay, such as VPN tunneling, streaming videos, online game, live broadcast, domain name system, voice over internet protocol, and trivial file transfer protocol. Okay, next I would like to share about principles of congestion control. So what is congestion? Congestion is a state occurring in network layer when the message traffic is so heavy so that it slows down network response time. So congestion occurs when too many sources sending too much data too fast for network to handle. So there are a few symptoms of network congestion, which is first, long delays, queuing in routers buffer. Second is lost packets, buffer overflow at routers. So as you can see at the diagram, there are different sources compete for resources inside network. So there are a few problems, which is sources are unaware of current state of resource. Sources are unaware of each other. So in many situations, it will result in below 1.5 Mbps of throughput, which is cause congestion collapse. Okay, now let's go to the last subtopic, which is TCP congestion control. So congestion control refers to techniques and mechanisms that can either prevent congestion before it happens or remove congestion after it has happened. Okay, TCP uses a congestion window and a congestion policy that avoid congestion. So so let's take a look about congestion window first. Okay, congestion window where sender should not send data greater than congestion window size. Otherwise, it leads to dropping the TCP segment, which causes TCP retransmission. So the sender should always send data less than or equal to congestion window size. The different variants of TCP use different approaches to calculate the size of congestion window. So congestion window is known only to the sender and is not sent over the links. So next is congestion policy, which is TCP's generous policy for handling congestion consists of following three phases, which is first, slow start phase, which is start slowly, increment is exponential to threshold. Second is congestion avoidance phase, which is after reaching the threshold, increment is by 1. And lastly is congestion detection phase, which is sender goes back to slow start phase or congestion avoidance phase. So that's it. Thank you.